While I still have this line extender out, I thought I'd talk about it a little bit. I know it's a foreign thing for most people. For one thing, note the case is a sealed clamshell type thing. Bolts together. Fins on both sides of the case. The lid actually becomes part of the heatsink when it's all, tied up, tightened up. If you don't know about cable on the poles, it's actually more like plumbing than cable you think of, normal flexible cable. It's actually a lot more like plumbing, and these are like plumbing compression fittings, except there's a radiation shield inside. Basically, there's two layers that the metal shield. And it's quite complicated doing these connectors. You have to core out the foam with special tools. That foam dielectric has to be cored out to a certain depth, and then the connector will go in there, and that way the aluminum, that's been cored out, the outer aluminum sheath, can sit between two pieces of metal in the connector and go under compression. Nothing wants to leak out. It has to be not only watertight, and there are O-rings in here, but it also has to be radiation tight. It has to have a super good connection and not leak any signal out. These old amps had test ports right on the outside. That's pretty much history on most amps. You don't see that too often anymore. In fact, I saw an illegal customer once hooked up to a test port on one of these LEDs. He ran his drop right to the test port, the 30 down test port. He would get a weak signal. Some of them had 20 down ports, some had 30 down ports. These had 30s. Other brands, nowadays they're going down to 20, simply because a lot of times you have to insert return into these ports. But that's getting way more than I want to get into. That's a thinner cable. Was going to this side. It's crushed, you can't really tell. 1/2 inch diameter though. Oh, that's beautiful. See, that's what makes cable not work well when this stuff happens. Maybe somebody replaced this LE and this was the real problem. I don't know. What probably happened is it was probably a rebuild situation, or somebody just yanked the housing. I don't really know where this came from, because the system that I used to work in must have come out of some other system. We didn't have return amps. At the very end we did in a small run. This is back in the day when we had the super trunks. We didn't have fiber. We were still running 400 megahertz. We eventually put a few nodes in. We got rid of the super trunk and put a node in. That was our first one node that we had. It was to replace the super trunk with fiber. And then eventually we split that up into smaller and smaller pieces. But this gear only did that first split pretty much. They had to get rid of this gear. So all these things bolt into the housing, and they got rails in the housing so they can dissipate the heat out. And almost all RF modules are done in these little hybrids. And even though this amp is really old, when I show you a newer amp, it's the same idea. In fact, they're mostly pin compatible. I could probably take a hybrid out of this new amp and put it into this old amp, and it would probably work. And we've even, in desperation, I've seen techs take forward, which are broadband hybrids, and replace the return hybrid, which only goes up to 54 megahertz normally, and it'll work. In desperation, I've seen all kinds of things. If you have enough gain, I've seen them bypass completely. If you don't need the gain. And again, in the old days, we had these potentiometers for gain and slope. Nowadays, the slope would be a plug-in equalizer, and in most cases, the gain's a plug-in equalizer too. I mean, a plug-in pad, which is an attenuator. It's a shorthand name for attenuator. So you got plug-in pads and plug-in equalizers. Mainly because I discussed before, you can't run RF through pots anymore and get kind of high frequency. This doesn't have any automatic gain to show you. But again, it's more of the same. One big change on these old units is this voltage range selector. So the further you get out in the plant, the more your voltage drops. And in the old days, most of us ran 60 volts. Nowadays, most systems run 90 volts. But at any rate, you get further out in the plant, and you don't have that 60 volts. You got maybe 45 volts at a far end. And apparently they needed, this was a situation like that, they have it all the way into 4. You know, if you had your full 60 volts, you'd put it in number 1. And as you needed it, and of course you measure your little 24 volt test port, make sure you're making your 24 volts right here. And so you put this in the lowest setting you can to get your 24 volts. It's regulated to a point, you know, just a passive linear regulator. But that's how they did it in the old days. None of the switching regulator stuff. And so there was a transformer, and you had different taps on the transformer, and that's what you're selecting with this unit here. Old school. Here's the power supply module. Here's the Ford. One will be the input and one will be the output. And again, these rails go into the cases rails and transfer heat into the you know, heat away from the amps. Here you can see the inside. These are called pin connectors because they come to a pin. You take the big cable and they adapt it to a pin. And there's a 625 width entry ports. And in recent times, a lot of companies have started using 625 diameter cable in most of their feeder lines. It has less loss than the old 500 we used to use, or even the 550 we used to use. Bigger the cable, the less loss you get per foot. This is a, I believe, a 750, which is, you know, 0.75 inches in diameter. Oh, U.S. systems, huh? And you can see the module has quick plug-ins. They fit standard F. You can put an F barrel right into here in a test cord. Look right into your output. You know, send a signal in your output, TDR it. TDR your input the same way. TDR is a time delay reflectometer. If you have a fault in your cable, you send a pulse down and you get an indication of how far you're. That would be a video in itself, so I don't want to go any further than that. Let's you see how far away your fault is, basically, or could be. And there's some circuitry in these boards, and that's just for the test points. And again, the later versions of these amps they use nowadays in this housing design don't have the test ports at all. You have to open up the unit. Some of them have little ports in the lid. You can take these caps off the lid and reach through the lid with a test probe. And 90% of techs I know never bother with those. And if you do, they end up developing leaks. It's almost never used. So hopefully more and more manufacturers are eliminating that. So a housing like this and this basic construction, even though this amp is very old and obsolete, well, elements of this housing, the spacing of these bolts and the basic width and length, this housing is still being made in a newer version. Because what happens is people have Magnavox equipment in their field. When they want to upgrade, say when we went from these blue modules to the gold modules, all you had to do was unscrew the module and plug in a new module and then adjust it. So you could do upgrades real simple. Of course, this, you know, is only good for such a frequency range. And eventually stuff gets what I call old amp disease, which is mainly a matter of aluminum. Even if you keep it clean and dry, and especially if it isn't though, eventually from opening it up, even if it's a good seal, a lot of times the seals go bad, of course, or people don't close them properly or don't keep the seals clean, or work on them in the rain or snow and don't bother to dry it off as well as they could. I was trying to get my old boss to get little packets of sodium silicate to put in these amps, LEs and amps, and especially the optical nodes. Because what happens is slowly, aluminum oxide is one of the strongest insulators known. That's why electrolytic capacitors, that's what aluminum electrolytic capacitors work on that principle. Aluminum oxide is a very good insulator, a very tough, good insulator. And this bare, shiny aluminum in these housings slowly dulls with age. And also this modular approach, this is nothing compared to how the trunk amps were back in this day. In this era, where these amps were used, the trunk amps were very complicated. It was a big unit, and each individual, like the bridger was its own module that plugged in. Each module had a metal, kind of like these things with the screws. They'd strip it in a row of modules. AGC was its own module. Everything had its own module. And they were all in these metal little things that all looked real pretty. But all the interconnecting and all that grounding to the housing, they developed really strange things later on. I'm sure if we knew what CPD was back then, we would have been seeing our problems as CPD. But again, we didn't have much of a return path, so it was just the forward distortion stuff going on. Basically, it's the same thing. If you got oxide in a connector, like that stinger I pulled out of here, that oxide starts to act like a diode at some point. Plus, you can see water was getting in here, and water would have killed the high end. So this, it had to be in operation for quite a while before someone discovered this. Yeah, oxide is like the biggest enemy we have in cable TV. You got to keep everything dry and clean. And then again, they expect you to work in the rain and snow. So, some guys are a lot more conscientious about drying things off before they close the lid than others. If you let everything get wet and say, F them, I'm get my job done and go. Close it up while wet, then the amp's life is really shortened. This is where an equalizer would go. There's none in this one. A pad would go in here. This must have been run in a really weak area. They were trying to get everything they could out of it. So they didn't put an input pad in. They didn't put an input equalizer. They had enough with the built-in gain control and slope control to control the levels. And again, like I said, they don't have these anymore. We really rely on our plugins nowadays. So a more modern unit, and this is a distribution amplifier. This family, this old Magnavox stuff, got sold to Secor. So if you buy these nowadays, they look different, obviously, but you can still fit the same basic. You could probably fit this module in one of the new units. The new housings have diagonal on the Magnavox Secor. Well, Secor bought it up now. And that's really smart because these get mounted all different directions and pedestals and everything else. They're really smart. If I was going to build a system today, I would build Secor. Unless I had a very generous donor who wanted to give me SA or something. But probably for the money, and I'm kind of talking through my hat here because I don't know. I'm presuming Secor is cheaper than SA, and I don't really know that for sure. SA, those got a reputation for being outrageously expensive on most of their stuff. And sometimes service on SA can be a little bit slow. I don't know if they've improved that situation. Anyway, this is a much more modern amp made by General Instruments. Now it's called, it was bought up by Motorola. And then from Motorola they became Aris, I believe now. And before General Instruments, it was by Gerald. I don't know if they exactly had that housing, but it's probably a slow evolution. I think they did have a Gerald. I remember the old Gerald amp said Gerald in big printing across. Gerald, real huge printing. Anyway, there's a lot of things in this amp. I don't want to go deep. This is a Bodie equalizer, which I believe is the little built-in tilt and correction. These covers here are just covers over more hybrids like this. And so these got hybrids underneath these covers, just like these hybrids. This is the return hybrid. This is the output hybrid. Well, actually, this probably has two output hybrids. It has because this has two outputs. One output goes directly to the output port, which could be used as like a trunk. It's not really properly a trunk amp, but it could be padded down with pads and used as a trunk line. This other leg can be, you can put a plug-in splitter here, and you can feed this way on a lower port here, or this way in a port here with the splitter, and you can actually put a directional coupler and have an uneven balance instead of an even balance, you know, in your split. And it gets real complicated from there. There's attenuator plugs for your return. Oops, this is scrap anyway, so I'm not really worried about anything. These big coils are just to pass power. You have to, just like the diplex filter I was talking about, where you've got to separate the forward from the return, you also have to separate power out of that mess too. So you're really triplexing power, forward, and return all together, and you know, taking it apart on this end and putting it together on this end. So you've got these fuse holders here, these ATC fuse holders, and even though this is 90 volts, and even though these are only rated for a much less voltage than that, they still use them for just direction, you know. They say, oh, they're not really supposed to be working a fuse, they're supposed to be using as power direction. We always put fuses in them. A lot of these amps came with shunts. Usually these came, I think, with well, these ones came with 20s mostly. Sometimes they come with shunts that'll never blow. But I like to see at least 20s in them. You don't want to go too low, because when there's a power outage and power starts up again, the new power supplies in all of these are, well, it's in the lid on this module. This fits in a metal unit, clam unit, like the other one did, but the power supply's on the lid side, so I can't show you that because I don't have that part of it. I wish I had the cover for this, because it shows all the directions everything goes. But like I said, this is a piece of scrap, water damaged, and it's been repaired once. They finally, with the old amps we had, there was no replacement. We would repair them a million times if they had to. Then they finally gave up on that and started splicing these in instead, or the more modern version of these. And so it's difficult. I could talk a lot about that, you know. But anyway, I don't want to get involved in the details that don't matter to anybody. These little boards here are called, different names for them. But basically, these are to make the amp more linear. So if you have a slight defect in the signal coming out, you can try to, these are called like bump boards, you can bump different, these are all for different frequencies, and you can change, and these are real fine changes too. These are when you sweep the amp, you want to get as flat of a signal as you can on the output across the whole spectrum of what it's rated for. And they're pushing this chassis up to a gigahertz nowadays. This is definitely not one of those, but this is probably a 750 megahertz. So all these little boards are for doing little corrections. And this one too, as a matter of fact. And, doesn't even matter, it's never going to get used again. And you can see a lot of surface mount components. If I took these hybrid, let's say this was a 1 gig module, and I took the 1 gig hybrid out of here, I could probably put it in this old dog, and I would improve its frequency response somewhat, but it wouldn't completely do it because it's just not built for it. It's got all these through-hole components, these big horsey inductors and capacitors and such. The chassis just isn't meant to go that kind of high frequency, where this is all surface mount. Everything's a lot tighter and shorter current paths. You don't have variable resistors anywhere in the RF path. Where you do have variable resistors, it's normally a DC control level, like this pot here is if you had an AGC plugged in. AGC would plug in right here. It's a metal can, and you have a pilot frequency in the high end somewhere that you choose in your system, and you've got to get a can that detects that one channel, that one frequency. And nowadays they even have analog and digital. In our system, they were too cheap to buy the digital. Even though the system's all digital, so they have one channel, they have one carrier, just a dead carrier for the pilot now, where we used to just use a channel. At any rate, you have to get this AGC module specified for your system and whatever you're going to use for what we call the high pilot. So we settle on a high channel and a low channel, and we have a known tilt between those two channels, and normally when we talk signals to each other, we say 21/7 or something like that, you know. And what we usually mean by that is high frequency over low frequency. And some people do it the other way, so it can be confusing, but each gang will have their own little conventions. Normally it's high over low. I had a boss that went the other way. So we all had to change for him. This thing is just a director, you know, just a little switch, but it's long like this so you can reach it from the lid if the lid was on, and there's a little slot in the lid so you can, instead of putting a switch in, they did this to save a little money. And this is what you would switch to engage the AGC module if the AGC module was plugged in. And that's kind of a complicated setup, which I won't get into because I could talk about AGC setup for a whole video. I just wanted to show you the elements of this unit. Again, these big inductors just route the power out, and then there's going to be big conductors probably in the back plane to carry the current across. This amp is a little bit unusual in that there's so many hybrids in it. You've got the return hybrid, you've got your input hybrid, you've got an interstage hybrid, which is kind of odd, not too usual to have an interstage hybrid. Usually it's just 2 stages, but input, interstage, and then 2 output hybrids, because it has actually 3 legs you can power out. And the one leg has got to be split if you're going to power off both, or you can send it all the signal this way and none that way, or vice versa, or you can, like I said, have a directional coupler and choose the amount. And these, of course, these smaller transformers and inductors, and this is probably for the return. You have a plug-in splitter for the forward. Actually, and these amps are unusual because the forward and return are both combined before the split. In most amps, they do it right at the outputs. But in this amp, maybe to save a little money and only have 1 diplex filter to 2, which I need for the 2 amps. I guess they put the diplex ahead. I don't know. I mean, these 2 amps definitely only do forward, but maybe they don't. Yeah, they would have to. Anyway, I wish I had the little chart here because it shows all exact flow, and I don't want to misstate it. I pretty much know how it goes, but this slot here is the main equalizer that would plug in here. It's a big blue plastic case over the newer ones, which makes them a lot easier to get in. The older ones are these flimsy little things you had a little tiny handle on them to dink around with. And this is where your input attenuator would go. These amps have real kind of a nice plastic attenuator, pretty much shaped like these guys. This is a blank, a 0, just a blank. But they have these with a number on top, and the number represents how many dB attenuation. Again, these are all zeros. This amp's been pretty much scrapped for anything useful out of it. People took all the parts out and threw it in the bin. I don't know what else I can tell you about this amp. I think I've covered the basics. I don't want to get too much into the weeds. But that's basically what they are. So input port. Yeah, I stole this from the dumpster. I tried to reuse it because I didn't think it was bad, but it was bad. I was desperate. We were out of amps. Again, these plug in the housing just like I showed you at that other housing. Pretty much the same kind of deal. These clips they put on these newer amps. I was talking about old amp disease before. You get this oxide layer building up in this aluminum, and it gets heavier and heavier. And even on these rails, they start to get oxide, and you start to get ground weirdness. They put these in to combat that, what I call old age disease. So these are all, and like so much of this stuff, it's all done in Mexico. So many brands are built in Mexico. Just to get labor a little cheaper, you got not to have the big shipping in, because these can be a little bit heavy. And again, old age disease fighters, trying to get a better ground between the case and the chassis that this slides into. And how does the ground get bad? Well, this is real typical. You know, you get a little, someone doesn't close the amp right, and the water leaks in the seal. And these amps, the housings are kind of cheesy. And there's a little bit of rocker to the housing. You really got to close it right, or it's going to leak. The bolts feel tight when it's not really necessarily sealed. So, anti-old age. And that stuff they found out, you know, as time went on. That module in this thing, you won't see any of that. It's stuff they learned as they went. Now in most modern modules of any brand, you'll see something like that. Well, I hope this wasn't too boring. Before I put you all to sleep, I'm going to end this one. I am going to still do a video on cable modems, but I'm really kind of struggling with that topic. I don't know how deep people will expect me to go on it. I'm going to try to shoot for a 10 to 15 minute video, but that's kind of like explaining what's in the Smithsonian Museum in 10 to 15 minutes, you know. There's so much to explain, and a lot of detail I want to explain, but I can't tell you everything about them. I can just have to make it understandable and simplified, and try to skip some of the cable jargon, which I probably will fail at because that's so ingrained in my head. Everybody knows what a trunk amp is. Everybody knows what a bridger is. This amp is not truly a trunk amp. This is what we'd call a distribution amp. Trunk amp would have a trunk amp output, which would be at a lower level but at a higher quality. That's kind of gotten obsolete because these guys have gotten so much quieter than they used to be. Noise was a big limitation for us back in the day, and these have gotten much quieter. I think the reason they used an interstage is to push that response, you know, above 750 megahertz. They want this design to support up to a gigahertz with the right hybrids and stuff. So I think at 1 gigahertz they're going to need all that gain, so they don't have to run so much gain, you know, through each individual amp. They can, as an audio, the higher the gain and bandwidth are kind of related. If you go lower gain, you're going to have a wider bandwidth, to oversimplify. So using 3 gain stages is probably what they were after there. Well, thanks for your patience.